Heidi Brennan, and I want to thank you all for attending today's workshop for our science coaches. Today's workshop is going to be focused on best practices in the elementary science classroom within science instruction, and our focus is going to be on grades 3 through 5. Before we go into best practices in science instruction, I think it's really important that we take a step back and we make sure that our teachers understand their standards. Many elementary classroom teachers don't realize that we have course descriptions at our level, so this is a great way to introduce it to them. Ideally for this activity, you'd have all the teachers in a room together and they would have their own devices, and you would have them as a team go through and pull out their course descriptions specific to their grade level. But for the sake of today's workshop, I just did some screenshots to show you the process to take back. So you'll want to go to cpoms.org, which is all things Florida standards, and you'll want to click on course descriptions and directory. From there, you'll choose grades pre-K to 12 education courses. Click on your specific grade band for elementary. From here, you'll see all of the course descriptions listed at the elementary level, and you'll scroll down to find science. And then from the drop-down menu there, you will see grades K through grades 5 listed in the course descriptions. This is a really important piece for your teachers when you get to this page. Make sure that they click the Export To button, and you can export to PDF or you can export to Word. And this document is great because it's nice and clean and laid out, and the teachers can see all of the standards listed, even information on which ones are annually assessed. Additionally, they're going to see the connections with the other content areas because mathematical practices, some mathematics standards, and some ELA standards that lead themselves to science are also listed there. But again, the important piece is that teachers have the standards in hand that they're responsible for at their grade level. Another great activity you can do for standards knowledge is printing out several copies of Appendix B out of the test item specs for grade 5 FCAT. It's great to sit teachers in groups, making sure there's representation from 3rd, 4th, and 5th. And then you can create a scavenger hunt where you have several questions that you've created that need to be answered using this document. I've used it before, and one of the great findings, for example, was the water cycle. I asked at what grade level that was a focus on, and the majority of the teachers said 3rd grade. But when you go through, you notice that it's actually a 5th grade standard. When we're talking about earth systems and patterns, that's when students start working with the water cycle. Now in 3rd grade, you'll notice that in physical science, they're building that conceptual knowledge of changes of state. So they're learning about how matter can go from a solid to a liquid. And again, this is a conceptual understanding where they're learning words boiling, freezing, evaporation, condensation, and what that means with water as it changes state. Then they build up in 5th grade and build on to the water cycle. Another thing I really like about it is you don't necessarily see it on this page, but in others we have what we call holes, and those are the standards that are taught only in 3rd grade but tested in 5th, and also standards that are only seen in 4th grade that are tested in 5th. So it really drives home the importance of 3rd and 4th grade teachers when it comes to science instruction. If they don't cover those standards, the students will never see them, and then they're assessed in 5th grade, and we wonder why we can't get our scores above that 50% statewide. It's a great aha moment. So if you have access to classroom instruction that works, the book lies out 9 categories of best practices or instructional strategies that help develop our 21st century learners. And this might be a term that you've heard of that leads itself to those more critical positions that are coming up, STEM careers, careers that haven't even been invented yet. These are important strategies that our students really need to have and practice. For the sake of today, I'm going to just focus on 3. We're going to talk about cooperative learning, which is a term you've probably heard about, but I wanted to discuss it a little bit more deeply in a science classroom where it's student-centered learning, meaning the students are reading procedures and problem solving and having that moment of lostness, and the teacher's facilitating. It's a gradual release. You're walking around the room, you're asking probing questions and giving guidance when it's needed, but you're really taking a step back and letting the student doing the learning with each other. Generating and testing hypotheses, again, important with inquiry. We need to let our students make their own discoveries. And then setting objectives and providing feedback is also a really important part that we'll work through today as well. So this is the big discussion, that time is a big issue in our elementary classrooms, and that's probably the number one reason that teachers say that they either don't touch on science at all or very little. And that's why a lot of them don't see it till just 5th grade. But that's a problem, because it's great if we can introduce it during the literacy block, and that's a strategy, but it's not the be-all, end-all. And there's a lot of concepts that students are going to have a hard time bringing back unless they have something tactile or great memory attached to it, an experience that they had. We'll talk about that a bit too. So what research has to say, NSTA Press has a great book, Designing Effective Science Instruction, What Works in the Science Classroom. And they go through several key points, but these 3 really lend themselves to today's activity. Engaging students in science inquiry to develop an understanding. Again, they're doing the learning, we're facilitating, we're assisting, helping them get to that understanding. Making use of formative assessments. This is a big buzzword right now. We hear about formative assessments a lot, and they weren't created to be a grade. The whole thought behind a formative assessment is a quick check, a way to alter your teaching. In science, the formative assessment is huge because you can use it at the beginning of a unit to gauge misconceptions. There's a lot of very difficult science concepts that lend themselves to misconceptions. We need to know what the students think before we can really tackle and assist them. A great example would be if you're a 4th grade teacher and you know you have to focus on the lunar cycle. You really want to know what your students might know about it going into it. So you would simply ask them the probing question, why does the moon appear to change shape over the course of a month? And it'll be really interesting, some of the explanations that you hear, and it's a great starting off point for your unit. And then develop student understanding through collaborative science discourse. You might have heard it as in talk moves. You might have heard of cite evidence reasoning. You might have heard of ADI, or argument-driven instruction. ADI is more secondary, but again, we can start helping our students with this science discourse at an earlier age, helping them not just say, oh, this happened and here it is. Say, okay, why did that happen? Explain it. If they ask, I wonder, ask them, how could we find out? These are really important conversations to have with the students to drive science content knowledge. So what I want to focus on today is the best practice in terms of inquiry is the 5E model. Now, this is something that was developed many years ago under a research team by Roger Bybee. And basically, it's trying to find the ways that students learn best with difficult concepts. And I have the article cited there, the research paper for you for your information at a later date. So the 5E model, the 5 E's. The first E is engage. This happens at the beginning of the lesson. It could be something as simple as you taking an item. You know that you're going to be working on gravity with your students, so you just walk up to the front of the room and drop something. Probably makes a loud noise, gets their attention, and then you can start probing right there. What happened? What caused the book to fall? You can show a picture. You can show a video clip. Anything to gauge the discussion with the students, and most importantly, the interest. You've got them hooked, and now you're going to dig a little bit deeper. You have the explore piece. Again, teacher's the facilitator. You're walking the room. Typically, you see in a science investigation, okay, class, the first step you're going to do is this. You might see the I do, you do, we do, where the teacher models it first. But the 5E model really is giving the students the responsibility. They're taking their learning into their own hands. You provide them with the procedure, let them work through it. You might provide them with their data charts. You might ask them to create them. So that's what the Explore piece is going to look like. Explain, after they've done their hands-on investigation or their research piece, then they're going to write and tell you, explaining that phenomenon. They're going to give you evidence. They're not just going to say because they think so. They're going to tell you why they think so, and here's the evidence to support that. Next is the elaborate piece. So an example there would be you just wrapped up insulators and conductors with your students. You want to see if they really understand what those are. So you provide them with a multitude of materials from foam, newspaper, aluminum foil, and a shoebox. And you tell them that you want them to create a solar oven, and there's a competition to see which group can melt a piece of chocolate the fastest to make a tasty s'more. So an example of an elaborate piece, something additional that you do to where the students can take the content knowledge they learned and show you how to apply it in the real world. And the evaluate piece, even though evaluate's coming at the end, that doesn't mean that's where the evaluation has to occur. You can do evaluation at the beginning to gauge understanding. You can do a formative assessment probe in the middle to see where they're at with their understanding. The evaluation piece also could be summative. It could be a multiple choice assessment. It could be an open response question that they need to write about. But that's the evaluation piece. It's happening throughout the lesson. Now I'm going to walk you through what that would look like in a classroom. I chose a 3rd grade standard, one that's actually pretty difficult for our students. And it's difficult because it's a tough concept, but also because they only see it in 3rd grade and they're assessed on it every year in 5th grade. And it's talking about investigating how plants respond to stimuli, specifically heat, light, and gravity. Okay, so here's the engage piece. Perhaps you show your students a photograph. You ask them what they see. You ask them what they think is happening. I also have 2 videos attached. For the sake of time, you'll have to watch those on your own accord. But both are set to music, and one shows a group of seedlings. When the sun is out, they start leaning towards the window, and as the sun sets and it becomes nighttime, they straighten back out, and the process continues again. As the sun rises, they start to lean towards the window again. Great way to get the kids psyched, excited, and start that thinking process. The explore piece. All right, so my science textbook didn't really have that great of an activity, or I want something additional. So I went to CPOMS, I typed in my standard, and this is one of the activities that came up. I see that the materials are pretty easy for me to come by. There's much more to this activity. This is just the first page of it. But this is something that the students can do to really discover their own thinking. I want to point out that this particular explore activity isn't going to be done in one day. It's something that they're monitoring over several days to a few weeks. So that's something important to keep in mind when you're planning your science lessons. It's important to know that they don't happen in one day and that one concept can be stretched over a couple of weeks. Now, explore can be hands-on, but it doesn't have to be hands-on. In this case, I pulled up a text complexity resource off CPOMS. These are fabulous. Not only are they great for supporting the explore piece with science concepts, they can be used in a literacy center to support science in your literacy block. They have these for grades 2 through high school. Honestly, there's only a couple for 2nd grade, but once you hit 3rd grade, they have several of these resources lined up for you. So they provide you with the article. And what's the best part is they also provide you with text-dependent questions and a writing prompt that go with that article. So here's where the explain piece comes in. Maybe you had the students read the article as a team. Maybe it's something that you have them do individually. Either way is fine. But here they're writing to explain their thinking. They're citing evidence from text. They're writing summaries. It's just a great piece to really gauge that explaining. When students write about science, it makes it easier for them to turn around and explain it to their partner. It makes it easier for them to bring it back at a later date. Another explain could be creating a type of picture dictionary. Now, phototropism, if you know your standards and you've looked, third graders do not need to know the terms phototropism or gravitropism. That concept, or excuse me, the vocabulary that goes with what they're learning here today is going to come later in middle school, but it doesn't hurt them just to expose them to the word. You can have them write in kid-friendly terms what phototropism is. And again, they're writing, they're explaining, and you're seeing they understand that plants react to the stimuli light by leaning towards it because it's something that they need for the survival. It's just an amazing adaptation that plants have, and here they are explaining it. They can draw the picture, using it in their own words, and then writing a sentence. The elaborate piece. All right, for students, I wouldn't show them the completed maze. This is for you. Simple activity to do. You don't need a lot of resources. Have the kids bring in a shoebox, get some cardstock, tape, and the plant. I only give the students scissors to cut the pieces of the maze. I cut the hole for them. I don't tell them where to put it. I don't tell them how many to put in there. I let them come up with that design on their own. And then we ask them. They need to be able to make inferences. Why are we doing this? What do you think is going to happen? That box is going to be sealed and we're not going to visit it for a couple days. What do you think is going to happen over a couple days? So now you're taking this additional hands-on piece, this really cool activity. You're letting them create it. So in 5th grade, when the students see a picture of a plant leaning towards a windowsill and they're asked why this is happening, it's going to be easier for the students to go, oh, I remember in 3rd grade we did this activity. Again, this particular activity isn't going to be done in one day because you're monitoring it over several days. But just a great elaborate activity. It's also great, again, if you're a STEM school and you need to introduce the engineering practices. So you would let your students, maybe their maze isn't working out the way they thought it was, you can let them redesign it and then go from there. Again, introducing that concept of reevaluating and redesign that comes with our engineering principles. Oh, one more thing. This is the interesting piece about science. I heard this from a gal who was doing research, and she had done an investigation with students in 2nd grade with soil, and they were learning which type of soil retained the most water, and she found it to be quite interesting. When she gave them the assessment, a lot of the students didn't answer it correctly, but when she asked them to verbalize, they were able to explain why one soil held water better than another. They got hung up on the word retain. So those are things that we need to try and think about as teachers. So for this, don't assume that all your students know what a maze is. You might have to show them a picture of a maze or explain with a quick video. Just something to think about through experience. I found that not all students know what a maze is. All right, the evaluation piece. Guys, again, this can happen at the end, but it doesn't have to. For the sake of this simulated lesson I'm showing you, it's something that I'm going to do at the end summatively. And this is why I'm choosing this way. We do the concrete representational abstract with our students in mathematics, but we have to remember that it's important to do in science too. So what that means is the concrete piece is the hands-on. It's them manipulating something. It's them making that discovery. The representational piece is when they're drawing a model, labeling it, recording that information, and what has actually happened in their investigation. The abstract is bringing it back to how they're going to be assessed. So I might do this great activity on how plants react to light, the stimuli of light, but if I don't bring it back and show them this format, they're going to have a hard time. And in all fairness, it's a great thing to do. You can find questions that go along with the standards by printing out or downloading the sample grade 5 FCAT. There's sample questions in there for each of the assessed standards. You also can inquire with your district or your school about what your access is to the IBTP, or the Item Bank Test Platform, which is where both of these questions came from. Word of advice, if you're one of those folks that has access to IBTP, make sure you read the questions and make sure they're keyed correctly. Something important to do. So, bringing it back to the abstract, my evaluation piece that tied in with my activity. All right, feedback to students is something that is also mentioned in classroom instruction that works. This is a fabulous resource out of Bay County, up in the Panhandle. This is a learning scale and goal. I've seen it in both Marzano and Danielson districts. This district happens to be Danielson. And I've seen it used with students at the beginning of a unit where they can gauge their own learning, where they think they're at starting off, and then revisited to see if they think they've got it. I've seen it used by teachers who weren't really sure how far to take a standard. What I mean there, grade 5 is a great example. I see a lot of teachers take and bring on density into the discussion with children. And density isn't a concept that we focus on with our elementary students anymore. We used to prior to 2007 with our old standards, but with the 2.0s, we don't do that anymore. So anyway, it's just a great way to assist you as a teacher to know how far to take a standard. Another great resource about it is you have a student or a group of students that are struggling with the concept. There's examples right here for you to use as sample progress monitoring assessments. Maybe you have a student that's really excelling and you want them to take it even further. There's activities to support those students as well. Okay, and lastly, getting the buy-in for science instruction. It's part of a school grade. It counts towards the school. If a principal wants to support the science instruction, if you as a science coach want to support the instruction, when you assist your teachers and do learning walkthroughs, share this with them. So this is for a Danielson district, and this is domain 3C for instruction. And I'm going to focus on the first bullet point. So Danielson says the classroom look for showing true engaged student learning is student enthusiasm, interest, thinking, and problem solving. Okay, well, what does that look like in a science classroom? You can look over to the side. Students are involved in investigations. They're hands-on, use of scientific method of problem solving, as well as the engineering design process. Again, these are just examples, but these are ways to help your teachers understand what science instruction really should look like to someone coming in. Again, looking at the very bottom, this is the last thing I want to discuss because it's really important. Suitable pacing of the lesson, neither dragged out nor rushed, with time for closure and student reflection. If you look over in the science classroom, adequate time for thorough understanding. This is huge. The standards aren't made for one day we're going to do this standard, tomorrow we're going to do this. I know time's an issue, but we need to give our students a chance to really completely understand these concepts. And that's why I love the 5E model. It's not something that's done in a day. It's not something that's done in 2 days. It's something done over the course of several days. It's revisited, and the students have a chance for that closure piece. Of course, you know your students best, and you know when you need to move on to the next concept, but that's a whole nother workshop. Just important to remember that as a best practice, the 5E model needs to be taken over several days. Well, I hope you gained some understanding and some best practices to take back to your teachers. Science coaches are extremely important. We need you in the schools, and we need you helping your teachers build that content knowledge and that comfort and excitement for science. So here's my contact information if you ever need any assistance or additional resources. And I've also added our secondary science director and our elementary and secondary mathematics specialists as well, if you could ever use their assistance. Thank you for your time. Have a great one.